All right, what's up, everybody? Thanks for hanging out. Thanks for tuning into our summer learning program. We're talking about substitution, and specifically, we're talking about systems of equations, and we're going to get on into matrices and a couple other things with this unit. So stick with me here, and we'll go over how to solve systems of equations and how to make sense of different equations in the same situation. So yeah, we'll get started. So substitution is going to be one of the simplest ways to solve a system of equations. So here's a system of equations. It's two equations, like I said, that are related. Whether you want to think of that as like being in the same situation, being on the same graph, but just kind of like two things that exist together. And the answer is going to be both an x and a y value that match or that solve the equation, or solve both of the equations, right? Okay, so it's going to be both an x and a y value that solve both the equations. So your answer is going to look like this, right? Like an ordered pair, like an x value and a y value. So this is what we'll fill in as we use substitution to solve this system of equations. So to solve this system of equations here, we'll start out. We're just going to solve for one variable, and then we're going to substitute the result for the same variable in a different equation. So what we're going to do is simply solve for this x here, and solving just means isolating. So isolating just means getting it by itself on one side of the equal sign, right? All by itself, isolated on the side of the equal sign. So what we would do to do that is add y to both sides. So we get x equals 5 plus y. And now what we're going to do is, since we didn't change this equation at all, we didn't change the truth of it, we just changed it around a little bit, we just changed what it looked like, we're going to read this as a statement now. Because this has truth to it still, right? X is equal to 5 plus y. So that means that we can use this piece of information elsewhere. More specifically, we can take this, and since x is equal to that, we can plug that right into that x. So what that's going to look like now is 3 times 5 plus y, because you have to multiply it by the entire thing, right? Because it's 3 times x, and x is 5 plus y. It's not 5, it's 5 plus y. And then we can't forget the rest of the equation, so we're going to subtract 4y and set that equal to 10. And this helps us because now we only have one variable. Yes, it's in two different spots, but since it's just one variable, we can solve for that one variable and then backtrack and solve for that other variable. So we'll go ahead and do this. First of all, I'm going to distribute. So we're going to have 15 plus 3y minus 4y equals 10. And then if we subtract 15 from both sides and combine these, so this goes to negative y and 15 subtracted from both sides. We get negative 5 equals negative y. And if negative 5 equals negative y, that means that positive y equals positive 5. So that means we can multiply both sides by negative 1. That's what that is. So 5 is equal to y. So in our y spot, we're going to put a 5. Boom, there's part of our solution, right? We still are missing this part, but we have one of the pieces, and we'll see that it's super easy once we have one of the pieces to get the other one. So we're just going to plug this 5, which is equal to y, right? We're going to read this as a statement too. Y is equal to 5, so we'll just plug this 5 right back up into there. And what we get then, sorry, that got a little messy. What we get then is x plus 5, or x minus 5, my apologies, right? Because it's x minus y, so we're going to do x minus 5 equals 5. And then to solve for x, what we would do, add 5 to both sides. X equals 10. Our solution then is 10, 5. So x equals 10, y equals 5. And this is the solution because these values, when plugged into their respective variables, solve both of these equations, okay? So that is first example of substitution, and we'll move on to the second one. Second one has another step, not necessarily much harder, but it does have another step. We'll erase that arrow. I already messed up this video once, so this is my second try, but we'll try it again. So similarly, we can solve for one of the variables, and yes, if you wanted to just get actually, forget I said anything. This one is going to be super easy. There's another number here, but it's going to be just as easy to isolate the x. So what we're going to do is have x there, and we're just going to subtract 2y from each side. So we have x equals 7 minus 2y. And we're going to take that and plug it in here. And so we'll have 4 times 7 minus 2y minus 8y, right, equals negative 4. Same thing, we're just going to distribute, make sure we do all our math correctly, and we can solve from here. So we'll distribute, and we'll have 28 minus 8y minus 8y equals negative 4. 28 minus 8y plus negative 8y. So we have negative 16y on this side, and we have negative 32 on this side if we subtract 28 from both sides. Right, so we have negative 16y once we combine these, and we have negative 32 on this side, so if we divide both sides by negative 16, we get that y is equal to 2. Nice and easy. And same thing here. Once we have this, all we got to do is just plug it right back up into the other equation. So we'll do x plus 2y, and we know that y is equal to 2. And if that equals 7, x plus 4 equals 7. And what plus 4 equals 7? Well, we know that that's 3, right? And so our answer to this one is 3, 2. X equals 3, y equals 2. Last example for substitution. This one's going to be a little more difficult, but it's really only going to be a little more difficult because of the original form. We'll see once we get past the original form. It's going to be pretty similar, but the numbers might not be as nice. So let's get into this a little bit. So we have 15x plus 3y minus 10x plus 6 equals 0. So this doesn't even look like what we've seen before. We have 1, 2 variables, another of that variable, and a number that doesn't have a variable on this side. But what we can do is just switch that around so that it turns into something that looks more familiar. So we can combine these like terms, 15x and negative 10x, and then we can subtract 6 from both sides of the equation. And what we'll get then is our new improved equation, 5x plus 3y equals negative 6. Yeah, you can see that. So once we have this, we can do the same process that we have been doing this entire time. I don't like how this one looks when I would divide it as much as this one, because I see that if I were to divide any of, or this whole equation by any of these numbers, the numbers wouldn't end up very nice. But if I were to divide this whole equation by the negative 2, that turns into a whole number, and that turns into a whole number, right? Or an integer at least, which is much easier to work with, at least from the start. That's what we love to see. So what we'll do is we'll solve for this x, and how we'll do that is we'll get x by itself by subtracting 6y from both sides. So here we have negative 2x equals 12 minus 6y. Divide the whole thing by 2, or by negative 2 we have x equals negative 6 minus or plus 3y. And so there's our new equations. I'll erase this work. Hopefully you got that. And so now we have x equals negative 6 plus 3y, and we can plug that right into there. And that would give us that right there. Laptop keeps shutting off. Same thing here, just going to distribute and solve. So we're going to distribute, we get negative 30 plus 15y plus 3y equals negative 6. Combine like terms. If we move this over here, we get negative 6, that would be plus 30, so we get positive 24. And then when we combine these like terms, we get 18y equals positive 24. And when we divide those out, over 18. Maybe you don't know that off the top of your head, but that's going to be 4/3 because if we divide both the top and the bottom by 6, we get 4/3. So y is equal to 4/3. And if we know that y is equal to 4/3, we can plug that back into this equation here, or any equation, right? As long as y is equal to 4/3, we can plug it back into here. So that's what we'll do, actually. Let's plug it into the bottom equation. But either way, since they're both true, and we already know that one of the parts of the answer is this, all we have to do is find the other part of the answer with this. It's like the key, you know. Once we have the key, all we have to do is unlock the door. So we can do 6 times y, which is 4/3, minus 2x equals 12. 6 times 4/3, drawing a blank, but it's 8. I don't know why I drew such a blank there. 8 minus 2x equals 12. And once we solve that out, we get negative 2x equals 4 divided by negative 2. And so our answer to this one here I'm so sorry. Completely messed that up. Thanks for catching me. Negative 2 4/3. That's substitution. Thanks for sticking with me. I'll get back to you soon talking about more ways to solve systems of equations, especially elimination and gradient.